Hi everyone, I've made this video to take you through the work that we did in today's lesson in case you weren't there or because maybe you didn't quite get anything that we were going over. So you can go over this in your own time and just check that you're understanding. And as ever, if you're still not sure, then please ask me. There'll be a few times in this video where I'm going to ask you to pause and do some working out yourself. Obviously, you can choose not to pause and then just copy the answers afterwards, but as ever, you're just going to be copying the answers and not the understanding. So it's really important that you try your best to answer some of the questions, even if you're not sure. Have a go at answering some of the questions and then use my answers as feedback, and if you're still not sure, ask me. So the title of today's lesson was about finding exact values for trigonometric functions. When we talk about trigonometric functions, we're talking about sine and cosine and tan. And to start the lesson, we're going to need to revise a little bit of Pythagoras. So I've got a right angle triangle here. I've measured this side, it's 3. I'm just checking, just show you. That is 3 centimeters. And you can see that this side here is 4. I've labelled it 4, but if I measure it, it's also 4. Okay. And if I measure the hypotenuse, the longest side, you can see that that is 5. Let me just check. I'm just going to move that a little bit. There we go. And you can see that that's 5. Okay, so the triangle has got sides of 3, 4 and 5. And it's a right angle triangle. So let's imagine I'm drawing squares on the sides of each of these squares. Well, if that's 3, that will be 3. And 3 times 3 makes 9. So the area of that square is 9. If this is 4 and this is a square, that will be 4 as well. And so the area of this square will be 4 times 4, 16. And the area of this square, well, if that's 5, that will be 5, and 5 times 5 makes 25. Now, the important thing to realise is that 9 and 16 makes 25. The areas of these two squares added together makes the answer of this large square. Now, that's not a fluke because it says 3, 4, 5. It always works. That rule, or that thing, always works on any right angle triangle. Okay, it only works on a right angle triangle. It won't work on a normal triangle. It has to have a right angle to work. So we start off by writing that down as a formula, and it says we're going to label the sides A, B and C. The most important side to get right is the longest side. We always call that C. So C is the longest side. A and B are just standing for the other two sides, and it doesn't really matter which one we call A and which one we call B. The rule is that A squared plus B squared equals C squared. You can see it work there. 3 squared, which is 9, plus 4 squared, which is 16, makes 5 squared, which is 25. And that works for any numbers here, provided that's a right angle triangle. So in any right angle triangle, this number squared plus this number squared always makes this number squared. And that's called Pythagoras' rule. He was a Greek guy who got the credit for inventing it or discovering it, basically because he came from Europe. A little bit of history. If he'd have got on a ship and gone over to Egypt or gone over to India and said, look at this rule I found, they would have looked at him and yawned and said, we knew about that ages ago. So he got the credit for inventing it, but he wasn't the first person in the world for finding it or discovering it. Anyway, we're going to use that rule, I'm sure you've used that rule before, to work out missing sides of a right angle triangle. And what we're going to do is we're going to look at 2 examples. One where we're trying to find out the longer side of a right angle triangle, and the other where we're trying to find one of the shorter sides of a right angle triangle. So let's imagine we're going to look at that one there. First thing I would do before we go any further is have an idea about what that answer is going to be. This is 4 and this is 5 and this is the hypotenuse, the longest side. So I know that I'm expecting an answer that's bigger than 4 or 5 because it's the longest. I start off by writing the formula down. A squared plus B squared equals C squared. Now, if I compare that diagram with this one, you can see that A is 4 and B is 5 and X is C. So I'm going to write that one more time, but with the numbers put in. So A is 4 and B is 5, and I'm going to write X where I saw c. And I'm going to use this now to work out what x squared is. So 4 squared is 16 and 5 squared is 25, and that makes x squared. 16 plus 25 is 41. So I'm going to write x squared is 41. So the area of that square would be 16, the area of that square would be 25, and that means the area of that square would be 41. Now for this lesson, I'm not going to bother working out what the square root is. I'm just going to leave it as what's called a surd. I'll write it down, a surd. Okay, I'm just going to leave it as x equals the square root of 41. Here, we're going to do the same thing. We're going to write down the formula one more time. But this time, the two numbers we've got are in different places. This time, we've got the longest side, and we've got one of the shortest sides. We have to work out the other shorter sides. Okay, here we had the two shorter sides and we were working out the longest side. Now it's different, so be careful. Don't just square the two numbers and add them like we did here, because here we're trying to find the longest side and here we're trying to find one of the shorter sides. So let's just write in, compare this diagram with this one, and you can see that A is 5, you can see that Y is where B is, and you can see that 7 is where c is. So let's write that in. 5 squared plus y squared equals 7 squared. I've just put these numbers in. 7 is c, y is b, and 5 is a. So 5 squared plus y squared is 7 squared. Work that out. 5 squared is 25 plus y squared equals 7 squared, which is 49. Well, what must y squared be? I can work that out by taking 25 away from 49, and that gives me that y squared must be 24. Just like before, rather than just working out the square root of 24, okay, that's my next line, and normally I would use a calculator to work out what the square root of 24 is, but for the purpose of this lesson, I want to work accurately and leave it as a surd, and I leave it as the square root of 24. So for this lesson, revising Pythagoras' theory, I'm going to leave my answer as a surd, as a square root. Y equals the square root of 24. Right, so before we go on to the further questions that I want you to try, I think it'd be a good idea for you to copy this into your book so you've got some neat notes. And I'd like you to copy this up in the way that I presented it. So you can see that my triangles are drawn with a pencil and a ruler. I want you to write that rule down. And then I want you to write this question down, exactly as I've done it, with the full working out and the answer shown here. And once again here, for this triangle, drawn with a pencil and a ruler, labelled like I've done, set with the whole working out. Please, 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 I hope you realise I wouldn't ask you to do something just for the sake of it, just because it's a waste of time. I really do think that when you write this formula out every single time, it really bangs it into your head and helps you remember it. Loads of people, especially boys, sorry guys, but you do it, because I did it when I was your age, I'm sure. You're just going to write down the answer. You're just going to put in some numbers here and work it out. Well, it's going to be easy come, easy go. If you do that way, you're not going to have something you can look back with and revise. So please, set out this diagram, label it like that, get that rule. If you like the highlighters, I think it's a good idea. Put a nice big highlighting box around that so it sticks out in your box, in your book. Also then, copy these examples up exactly the way that I've done it. I'm going to want you to do the next set of questions in exactly the same way. So, what I'd like you to do please is just pause this video at this point so that you can then just copy these notes up. And then once you've finished copying, proceed to the next part of the video and click play. Thanks. Okay, well hopefully you have copied those notes up, these notes here, because what I want you to do now is work out the answers to these in the same way. So you've got two examples here, one where you were trying to find out the longer side and one where you were trying to find out one of the shorter sides, and you've got examples and working out here. Now there's two examples for you to try. Okay, once again, one where you're trying to work out the longer side and one where you're trying to work out one of the shorter sides. It's really important, I was saying this in the lesson, that you identify the longest side every single time. What I've done here is I flip this triangle over, you can see that this 8 is not the longest side. So here, it's the longest side. How do we know? Well, firstly, we can see, just looking at it, that it's the longest side. But also we can see that it's opposite the right angle. It's facing the right angle in the triangle. In the same way, this is the longest side. It's facing the right angle. We can see it's the longest side. So in this diagram, even though the triangle's flipped upside down, this is C, and that's A, and that's B, or the other way round. What's important is that that is C. Okay, now what I want you to do is pause the video, and I want you to try and work out the answers for X and for Y. Now, once you start pressing play again, I'll be taking you through the answers. If you've tried your best to work out what X is and what Y is and you're not quite sure, then once again, go through the working out as I'm doing it. So just watch the video. Once you've got enough of the understanding, pause the video and then try and do it yourself. The more you do yourself, as opposed to just simply copying it off the page, the better will your understanding be. Okay, so if you need to look at a bit of the working out on the video that's coming up, fine. But just watch enough of it to understand, and then you try and do it yourself. Okay, press pause now and try and work out what X and Y is. On the next part of this video, I'll be showing you the answers. So I hope you've had enough time now to work out what the answers are to X and Y. In a moment I'm going to show you the answers by taking you through the steps in the working out. If you weren't sure how to do it, don't just watch the working out right from start to finish. Just watch enough of it to try and understand, and then you try and do it. Okay, so it's really important that the less you copy down and the more you do yourself, the more you will understand, and the more you will be able to do this, and the more you will be able to remember. Okay, so look at this diagram here. First of all, you write your rule down. Sometimes in an exam you can get marks for just writing that down, even if you do nothing with it. A squared plus B squared equals C squared. Remember that formula. That's A, that's B, that's C. So let's write that in. 3 squared plus 7 squared equals X squared, because we put an X here. Okay, 3 squared is 9 and 7 squared is 49 equals X squared. So X squared must be 49 plus 9, 58. And to work out what X is, if X squared is 58, to work out what X is, X will be the square root of 58. And remember, for the purpose of this lesson, we're just going to leave it as a third, the square root of 58. So don't bother working out what that actually is as a number. Here, once again, write A squared plus B squared equals C squared. It's important to realise that this is C. It's the longest side. So C isn't always the number that is sloping down, the side that is sloping down. It depends what way round this triangle is. And you can see that this triangle is upside down compared to this. This is C. And then that is A and that is B, or the other way round. Remember, it doesn't really matter which one is A and which one is B, as long as we get the C correct. So, Y squared instead of A, 8 squared instead of B, equals 10 squared instead of C. So we're just putting the numbers in for A, B and C. Well, Y squared plus 64, that's what 8 squared is, makes 100, that's what 10 squared is. So Y squared must be 36. How do we work that out? 100 take away 64 must be 36. So Y is the square root of 36. Okay, we're leaving things as a third at the moment, but because that's got an actual square root and it's easy to find without a calculator, you could write down 6 if you wanted to. Now, it's really important that you understand how to work out missing sides using Pythagoras. This is something that's on the higher paper and also on the foundation paper. And it's really important that you use it because or you're confident using it, because it's used lots of times as a foundation for more difficult stuff on the higher paper. So without knowing or being confident with Pythagoras, you can't go on to some more complicated work that uses it on the higher paper. So if you're not sure about this, I would really recommend going on Corbett Maths and looking at some of the videos on Pythagoras and doing some extra practice. And remember, with all the Corbett Maths, or most of it, there's the answers as well. Okay, so let's just pause a minute. We're going to pause the video and then we're going to look at how we're going to use this in the next set of questions. Okay, so now we're going to look at applying what you've just learned. At this stage you should be fairly confident, or very confident, in working out a missing side in a right angled triangle using the other two and using Pythagoras' rule. And we're going to use that to do some trigonometry. What we need to know on the foundation level and also on the higher level, especially on the higher level, is how to work out without a calculator what the sine, the cos and the tan are of 45 degrees, of 30 degrees and of 60 degrees. We're going to come back to that in a minute, but first of all we're going to apply what we've been working on to work out some missing sides. So here is a 1 by 1 square, okay, and I want you to work out what the angles must be here. Well, obviously that's 90 degrees. You can see what that diagonal does. So I want you to work out what this angle is here and what this angle is here. Also, what I want you to do is I want you to work out the diagonal of this square. How would you work out that? Well, look, you've got a right angle. So it means you've got a right angled triangle here. And you can apply what you've just been doing to work out the answer of that, leaving your answer as a surd. In the same way, we've got an equilateral triangle here. You know what the angles of a triangle add up to. You should know what the angles of an equilateral triangle are. But if you don't, you know what they add up to, and you know if it's an equilateral triangle that the angles are the same. So you can work out what this angle must be, and this one must be, and this angle here must be. This line here cuts the triangle into two identical pieces, into halves. So you should be able to work out what these angles here are. Okay, so I want you to work out what the angles will be, and I also want you to work out what this height must be. How would you work out that? Well, here's your right angled triangle. So actually we could forget about that bit here. Here's your right angled triangle, and you can then work out what this must be using Pythagoras. If this is 2, you can work out what that is, of course, and then you can use two sides in a right angled triangle and work out what that must be. So pause the video and then we're going to go over what the answers are, and then we're going to use that to work out the sine, cos and tan of 45, 30 and 60. So stop the video or pause the video and then we'll go over the answers. Okay, this is the part of the video where I'm going to take you through the answers you should have got from that last activity. Once again, if you just copy everything I'm doing, that's better than nothing. So if you really cannot do anything else, then please do copy what I'm doing. But what I want you to get best as possible, and this is why I'm making these videos for you, is to get the understanding. So try and watch a part of it. Better than just copying it would be, if you really don't get it at all, watch the video, then stop the video, and then you try and do it from memory rather than just copying. That will really help you. Okay, there's two things we need to do in this triangle or this square. First of all, we need to work out the angles, and we also need to work out what this diagonal is. So let's work out the angles. Well, that's 90 degrees. They're all 90 degrees because it's a square. So therefore this will be 45 and this will be 45. That diagonal cuts the 90 degrees in half, and so therefore of course that's 45 and that's 45. In the same way, in this triangle here, it's an equilateral triangle, so that is 60 and that is 60 and that is 60. And in the question, the line or the triangle was cut in half by a vertical line, and so therefore that is 30 and that is 30. So first of all, that's what you should have. Now let's work out what the sides are. I've got this square here, and I was told that that is 1 and that is 1. What I'm going to do to make it a bit more simple, this is quite a nice idea sometimes, is just home in on the bit I want. I just want this right angled triangle. I'm trying to work out what this diagonal is. So rather than drawing the square, I'm just got this triangle. Okay, and let's pull off from here the information we need. That's 1 centimetre and that's 1 centimetre, and I'm trying to work out what that is. We'll call it C because it's the longest side. Yes, let's use what we've been doing to work out what that side is. A squared plus B squared equals C squared. A is 1 and C is 1. 1 squared plus 1 squared equals C squared. 1 squared is 1 and 1 squared is 1. So that's C squared. So 1 plus 1 is 2. C squared is 2. And so C is going to be the square root of 2. Just like before, I want to leave that for this particular activity as a third. And I'm going to write that in here, the square root of 2. So here's my triangle, 45 degrees, 45 degrees. If that is 1 and that is 1, this side will be the square root of 2. Okay, let's go to this triangle. Once again, to avoid being confused, I'm just going to draw the right angle triangle that I want. That's right angle. This is 60. And this is 30. I need to work out what this height is going to be. The height of that triangle. Well, I know that's 2 because it's a 2 centimetre all the way round this triangle. And if that's 2 and that line cuts this in half, then this will be 1. So once again, let's write out that formula. A squared plus B squared equals C squared. Let's make sure we get the right letters round the right way round. The longest side is C, that's 2. 1 for A. And B we're going to call H. Right, 1 squared is 1 plus H squared makes 2 squared, which is 4. So H squared must be 4, take away 1, 3. H squared equals 3, and so H is the square root of 3. So I'm going to write that in here, the square root of 3. So in my second triangle, I've got 60 and 30, and the sides are 1, 2, because they were given to me, and this one would be the square root of 3 because I worked it out. Right, before we go on to work out the sine and the cosine and tangent, we're just going to go a quick recap over yesterday's lesson to make sure you remember how to work out those things. So I gave you these formula triangles before in yesterday's lesson, and I gave you a way of remembering it. Some people say Sokotoa. This way some Olympians have come and helped to organise athletics. It's just a way of getting some Olympians have come and helped to organise athletics. Here's my one. Sickness on holiday comes after having tons of alcohol. Or you can make up your own if you want to. The important thing is you get the sequence of letters. How does it help? Well, it tells you that the sine is the opposite over the hypotenuse. The cosine is the adjacent over hypotenuse. And tan is the opposite divided by the adjacent. So whenever you see a question that involves opposite and adjacent, it's tan. Adjacent and hypotenuse, it's cos. Opposite and hypotenuse, it's sine. So sine of the angle is opposite divided by hypotenuse. Cos or cosine is adjacent divided by hypotenuse. And the tan or tangent is the opposite divided by the adjacent. And it's really important that you get those sides nailed in and you know how to get it. So remember this saying, remember these formula triangles. You can do them in an exam, write them out, it's not cheating. Okay, and it helps you remember what sides go with what ratio, tan or cos or sine. Okay, and we're going to use that now looking at the triangles we've just worked out to work out the cos and the sine and the tangent of certain degrees. So using what I've just shown you and what we've done today's lesson and yesterday's lesson, we're going to put that all together to work out what the sine and the cosine and the tan of 45 degrees is, and what 30 degrees is, and 60 degrees. So let's look at 45 first of all. I'm going to write it out. Sine of 45 equals cos of 45 equals tan of 45 equals. Right, so what is the sine? The sine is the opposite divided by the hypotenuse. Remember, sickness on holiday. Sine, opposite, hypotenuse. So here's 45 degrees. The opposite is 1 and the hypotenuse is 2. Let's just write that out. The sine is the opposite divided by the hypotenuse. Okay, the opposite is 1 and the hypotenuse is the square root of 2. So opposite is 1 and the hypotenuse is the square root of 2. What about cos? Cos of 45. Well, the cos of 45, cos is adjacent over hypotenuse. How do I know? Comes after having. Sickness on holiday comes after having cos adjacent hypotenuse. So, look at your diagram. What is the adjacent and what is the hypotenuse? Write the answer in. What about tan? Tan, tons of alcohol. Tan is opposite over adjacent equals. Put in the numbers and write that down and work it out yourself. Now, we're going to go on to now, because I'm going to leave you to do these questions. Now we're going to do the same thing here, but for 30 degrees and 60 degrees. So, let's write down sine 30 degrees, cos 30 degrees, tan 30 degrees. Okay, what is sine once again? Sine is opposite over hypotenuse, just like it is here. It's always opposite over hypotenuse. What's cos? Adjacent over hypotenuse. And you can do tan yourself. What about 30 degrees? Well, look, here's the 30 degree angle. I want to know what the sine of 30 is. Let's just turn that round like that. Here's 30. Here's the side that's opposite, and here's the hypotenuse. So for 30 degrees, the opposite is 1 and the hypotenuse is 2. Let's put that in. The opposite is 1 and the hypotenuse is 2. So the sine of 30 degrees is a half. Do the same thing and find the cosine of 30 degrees, the cos of 30, and the tan of 30. Now we're going to do underneath here, we'll do sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees. Remember, sine is opposite over hypotenuse. Let's look at that 60 degree angle. If that's 60 degrees, what's the side opposite? The square root of 3. The opposite is the square root of 3. And the hypotenuse is 2. That's my answer. The square root of 3 divided by 2. That's the sine of 60 degrees. Okay, I've shown you how to do some of them. What I want you to do now is press pause and work out the rest of them yourself. After a short delay, I'm going to go over these questions myself and show you the answers. At the very least, you need to copy those answers into your book. But better still would be to try and understand it, okay, as much as possible and work it out yourself. So even if you don't get this at all, watch the whole video and then you try and do it from memory. If you get a bit of it, stop the video and try and do what you can. The more you do yourself, rather than just simply copying, the better your understanding will be. Okay, pause the video now and have a go. Okay, hopefully you've worked out the answers yourself. Okay, but this is how we're going to do it. I'm just going to check the answers we've got. So the cos of 45 is the adjacent over hypotenuse. So if that's 45, what's the adjacent? 1. What's the hypotenuse? Square root of 2. So it's 1 over the square root of 2. If that is 45, the tan of 45 is the opposite divided by the adjacent. The opposite is 1 and the adjacent is 1. So it's 1 over 1, which is 1. If you weren't quite sure and you didn't do those, maybe you could stop the video and try and do these questions here before you see my answers. Once again, I can't say this enough. The more you do yourself, the better your understanding will be. Even if it's a small amount, don't worry. Right, cos of 30. So, looking at this triangle turned round, the cos is the adjacent divided by the hypotenuse. If that is 30, that's the adjacent, square root of 3, and that's the hypotenuse 2. So it's the square root of 3 divided by 2. What's the tan of 30? If we look at that 30-degree angle, 30, the tan is the opposite divided by the adjacent. Opposite over adjacent. The opposite is 1 and the adjacent is the square root of 3. What about cos of 60? Cos, or cosine, is adjacent over hypotenuse. It's always adjacent over hypotenuse. Look, adjacent over hypotenuse, adjacent over hypotenuse, and adjacent over hypotenuse. It's always those two sides. And for this particular triangle, the adjacent is 1 and the hypotenuse is 2. So 1, 2. Finally, the tan of 60 is the opposite over adjacent, and the opposite is the square root of 3, and the adjacent is 1. And the square root of 3 divided by 1 is just the square root of 3. Now, even if you didn't get that, what you need to do is have a record of this in your book. The easiest thing to do would be to just simply copy down from this sheet straight into your book. That's great, that's fine, it's better than nothing. But what would be really helpful for you would be to stop this video and try and do it from memory. Try and work this out from scratch. The more you can do, even if you can just do a little bit, the more you can do on your own, the better your understanding will be. Okay? So, I hope that video was helpful to you, and we're going to look at these things in next lesson. Okay? As ever, if the video wasn't any help, there's something you're not quite sure about, drop me an email, drop me a message, I'll give you a hand. I've had a few Zoom lessons with individual students in the classroom already. I'm happy to do that for anybody in the group to help you understand. Cheers guys, thank you, bye.